before on my end, and we are about to start this. I hope everyone are ready. If you are ready, the chat is available. Yeah, you can just comment that you are ready. So I think I've already been introduced. Trying to reach out to someone. Okay. Yeah, we have to get this thing started. Um, Hello, is one of the Armenia? Hello.
Okay, good evening, everyone. Can you hear me?
Yeah, I can hear you. I can hear you. Isn't it?
Okay.
Is any of the
Just give us like a minute, to get it started.
Okay, good. Yeah, because
Thank you. Yeah. So good evening, everyone. Once again, I'm pleased to welcome you all to another session of our data structures and algorithm lectures. Yeah. So last week, we had a deep dive into big O analysis by Mr. Jonathan. So tonight we'll be exploring data structures and how to approach, lead code questions. Yeah. So and with us tonight is Mr. George Muba. So Mr. George Muba will be leading today's, tonight's session. He's an experienced Java engineer with vast knowledge in data structures and in designing scalable systems. So please give him your attention. Yeah. So Mr. George, you have the floor now. Thank you.
okay, thank you there so much for introducing me. I'm Liberian, so my accent might be a little bit lighter than what you have, constantly hearing. So today I'll be leading you through this DSA session. I'm Josh. I'm a software engineer at ARSM, and I'm also a software engineer at Rovia Gate. So I have a lot of experience in Java and other programming languages, but as for this session, we'll be focusing on data structures and algorithm thinking in Java. So as you all know, if you are going to an interview, they are expecting you to have the basics of problem solving. They are expecting you to be able to solve problems using the fundamental understanding of computer science, that is data structures and algorithm. But there are steps usually when you try to go on lead code and try to solve some of these lead code problems, what you will experience is that these problems they are like random. These problems are like random, and you trying to find your way through sometime on your own can be a little bit depressing because you have all of these random questions that will be thrown to you. Like if you're not experienced with it, it becomes an issue. And most people usually fail their coding interview. It is not because that they are not like experienced, because even me, I failed Microsoft interview before. So it's not because you are not experienced, it's because you don't have the skill set that is needed for problem solving. So in most cases, if you do not have the skill set, what you will experience is that you will feel that you are not that smart enough, you are not capable enough. So this is what I'll be carrying you through this maybe 4 or 5 months. We will be solving a lot of lead code problems. As you can see, on lead code I solved 292, and then on some other coding platforms I have solved over 400, and then yeah. So I've been coding for the last maybe 13 to 14 years of my life. So I've been in this field. So I've seen a lot. I've passed a lot of interviews. I've failed a lot of interviews. So I will be sharing my experience with you on this journey so that you know you don't fail in your coding interview. You don't feel like you are not that smart enough to pass, maybe to break into the industry and become a software engineer. So we get to our first slide. I have a question. Someone have a question? Or someone is just connecting? If you have a question,
no. Go ahead.
Okay. So, the first thing here is last week you was taught about big notation and isotopic notation on analyzing and visualizing algorithm. But today I want to take you deeper. I want to take you into the maze of problem solving. So the first thing we are going to look at is approaches to solve problem. Lead code is not a random thing. It's a skills you have to build. And we will firstly talk about data structure. Data structure, ways to organize and store data efficiently. So when you hear about data structure, what should come to your mind is that it is a way that you structure things in computer memory to solve problem. And then algorithm is a step-by-step procedure used in problem solving. Most people, when it comes to algorithm, they think it has to be something of a mathematical model. But really, it's not a mathematical model. You encounter algorithm every day of your life. For an instance, you usually perform an algorithm in the morning. That is, you do your hygiene. You try to bathe. You try to make sure you get you get your things well structured. So that is like an algorithm that you perform every morning in solving your hygienic problem or your hygienic task. So algorithm to a simple building blocks are just like procedures in solving problem. That is just what an algorithm is. It's just a procedure in problem solving. So the step you take, but as it relates to computer science, we will talk about it being like a step computer used to solve problem. That is what an algorithm is. And in this our journey, we will be taking the row path approach. That is to say that we will be solving problem based upon a roadmap. We won't be solving random problems because the idea is not for you to solve random problems. The idea is for you to learn in pattern. So that is just the basic thing about algorithm. Now, why you need to learn DSA? A lot of time in the industry, people say DSA is not important, but DSA is actually important in a sense that number one, enable you to solve problems, enable you to think as a programmer, not just thinking about solving a particular problem, but how efficiently can you solve a problem. Like now when I write code, I'm mostly thinking about how fast that code can be, how efficient that code is. It also enable you to be able to visualize code. And take for an instance, if you ever program, maybe you ever written code relating to a heap and you know how to use a heap data structure, maybe throughout your DSA career you have done it before, but if you did that, you will realize that most of the time some of these concepts, like I remember I was writing Redis in Rust the last time I was trying to create Redis in Rust. So I had an issue where I had to pass the main table and I was like, why can't I use a heap here? Because heap will always give me the k largest element. So I was like, let me just use a heap. I didn't get that knowledge from my own. I built that knowledge from DSA. So these are some of the areas that DSA help you. When you are building cache, DSA will help you a lot because a cache is simply a doubling linked list in a hash map. So you will see throughout DSA journey, you will start to see how your problem solving will improve. Also, it's the foundation of software engineering and design. If you don't learn DSA, a lot of things you have to learn it through the brute force approach. That is to say that maybe you have to do working open source for a long time to learn some of these things. But companies don't have that time to waste on you. Companies want an engineer that can think in pattern, can solve hard problem. That is what company wants. So they don't care. That is the only truth. It's like a horses of courses. You either do it or you forget about it. So there are some platforms that you use for coding interview. I think Facebook, say Microsoft use, I think Codify. Yeah, Microsoft use Codify. So there are some platforms you use for coding interview, like um uh they got a lot of one. Argo Esper, Lico. There's a lot of platforms they use for coding interview. Cold War, yeah. But all of these platforms, the simple thing they are trying to do is help you think in terms of everything in terms of algorithm, how to optimize time and space complexity. I'm sure if you attended this gone session, you will realize that you already did a lot of these things. I don't want to bore you down with a lot of slang, but the idea is just that lead code is not about tricks, it's about pattern. If you don't know how to solve to think in pattern, you won't be able to solve coding interview question. Now, there are some things that you need to know before you start jumping to solve problem, or else when you start to solve these problems, you might likely not go further. You might likely give up. That is the honest truth. So we have to take this session to build your mindset so that you don't defeat yourself. You don't say, this thing is too difficult for me. I don't know how I'll be able to get this thing, to get through this procedure. So we will try to talk about the mindset of a coder. The mindset of a programmer is not to memorize, even though memorizing is part of the process. But the mindset of a programmer is you need to have to be able to solve problem over memorization. When we talk about solving problem over memorization, you want to have those key concepts. You want to have those key concepts that are key, that you know, like these are the concepts that I already know, and I can solve problem using these concepts. So these are the concepts that I'm confident with. You want to have those concepts over memorization. Take for an instance, instead of you remembering every problem, you want to remember mostly the pattern. So if you see a pattern, like you see a pattern relating to sliding windows, you know that yes, there's a sliding window problem. I can solve it in sliding window. There's a heat problem. There's a dynamic programming problem. There's a gradient algorithm. This is Kendi's algorithm. This is Brian Kennedy algorithm. You see that problem, you realize that, oh yes, I can solve this. But you don't want to remember problem. Secondly, you don't have to be a genius. What you have to be is you have to be consistent in problem solving. So if you see here, we're having the number one coder on LeetCode. I think I should get his platform. Is a CPS. Okay. I think I should have his profile. Okay, so this is like, I think he's the number one ranked programmer on LeetCode, that he's the number one. So if you see something you will realize about this guy is that this guy solved every problem on LeetCode. But notwithstanding, look at his level of consistency. Everything is coding. So he is a man that do not have to prepare for coding interview. If you probably call him now, because currently he's a senior engineer, a staff engineer at Google. So if you call him now to solve problem, to do an interview, he's just ready to do the interview. He won't be like, oh, I have to go and prepare. So this is one of the mindset you have to build. You have to code every single day. I'm sorry to say, but to be an expert in DSA, you just have to code every single day, maybe one problem a day. It has to be a routine to you. That way you will grow faster than you trying to code today, tomorrow you miss the next day. You will make it. Also, confusion. A lot of time you will get confused when you are learning DSA. You will notice that you can't solve this particular problem without tweaking a little bit. Sometimes you'll get confused. The best thing to do when you are confused, the best thing to do when you are confused is you should embrace it. Take for instance, I was at the office today I have a task where I was to build a scheduler on Windows because the current scheduler we have is not running the task. I don't know about Windows Server. My GM there, he probably get a lot of idea on Windows Server, so uh, I managed to write the executable using one of the agent there. But then when I tried to run the scheduler, it just couldn't run. And then I had to be tweaking that thing, tweaking that thing. You have to embrace confusion. It is part of the job you do. As a programmer, you will always be a little bit confused. There will never be a time in this industry that you are totally like free, like you really know what you are doing because innovation requires confusion. So you have to embrace it. It's part of the learning process. So do not be afraid when you are facing difficulties, you are confused. You have to learn how to embrace the confusion and then go with it. And then try to although you most senior although they are confused but they know where they are going, but sometimes when juniors are confused they are burned out. So these are some of the things that you have to embrace: confusion, and you have to accept it. Now I'm confused, but after an hour or two I won't be confused again. If I can just take my pen and walk through this algorithm, I won't be confused. So that is something that you have to embrace. Feeling not smart enough is a common thing that happens when you are lead coding a lot. It even happened to me like a few months ago. I spent 54 days solving the lead code daily problem, and then I experienced I experienced that I experienced that there was this problem with lead code started to bring a lot of problem relating coordinate, and I wasn't good in geometric coding. So because I wasn't good at geometric coding, I was confused because I didn't have the basics. So I had to go back, go and learn the basics. And then when I did Microsoft interview, I was asked something around, it was I think a famous tree. It was a tree problem, but yeah, a tree or a graph problem, but it was really hard. I found a way to solve it, but my code ran in square time. And if you did the DSA session, you will know that it was a horrible solution I came up with. So probably another candidate was better than me, but that is just it. Yeah, you don't have to take the disappointment to have to think that you are not better enough. You have to realize that maybe there was a candidate that was better than me, but if I train harder, I will be better than them in the future, or I might be given another chance rather than take the disappointment to heart and start to feel like I don't have to do this thing. I'm not called off to be a software engineer. You have to embrace it. It's part of the process. You will fail interview. You have to take it as part of it and just let it go and keep training. Don't get tired training. Keep training. At the end of the day, you become a master. So that I just want to put that out there for you, so you don't go getting burnout, feeling depressed. So these are something that even we that are experienced with this process, we run into it a whole lot of time. So try not to make yourself depressed. The next thing is structural learning. So the last thing you want to do on LeetCode when you are learning data structure, the last thing you want to do, you don't want to jump around solving random problem. This is key thing we keep stressing on. Do not solve random problem. That won't help you. There's a lot of roadmaps on the internet. One of the roadmaps that I know of is called the Blank 75. This one is easier. I think I've solved all the questions on the Blank 75. I think even LeetCode 150. I'm currently now resolving it because of this class. But this one is another one, LeetCode 150, and then you solve this one, and then you solve LeetCode 250, and then you solve this one is actually 800 problem strong. This is like 800 problem strong. So this is 800 problem strong. And then you solve this one, and then you go to Strava. So LeetCode 150, LeetCode 150. So yeah. So this is LeetCode 150. I'm currently resolving a lot of the problem here. So this is LeetCode 150. So this one is like a roadmap. You solve the stages. Oh, I didn't reset the bit manipulation. I will reset it. So this one you solve the stages, and this is how you solve algorithm problem. You first start with arrays and hashing. You understand how to manipulate the array. You learn about two pointers. You understand this is how we will be approaching it. If you don't have a neat code profile, you can try and get to neat code and neat code to this website and then create a neat code profile. It's free. So you come here and then you solve all the arrays question, two pointers, you solve all the ones relating to stack, binary search. This one is like easier. Sliding windows, linked lists, trees. You come to try, you solve all the tries problem, backtracking, you solve all the backtracking problem. This one is like priority cube. If you know about priority cube, it's a heap. It's just a heap. You solve all the heap question, you get to intervals, and then you solve most of the intervals question, and then greedy. So this is how we will do in this class. In this session, we'll be hosting this session every Saturday. We will solve all of this problem in LeetCode 150, and you will have all of these patterns in your problem solving set 2K. Because once you have these patterns in your problem solving 2K, then the next challenge becomes whether you can drill that toolkit to find the exact pattern to solve that problem. If they're asking you something related to a stack, can you check in your toolkit and find a monotonous stack and solve that problem? So these are some of the techniques I'll be teaching you how to figure out words, the moment you hear words to relate it to a problem. But as you solve problem, you will see those patterns will appear. This is just what I'm telling you, pattern over questions. There are a lot of questions you need to solve, but you don't have to solve all the questions to be good at DSA. You have to have a lot of patterns on your shoulder. So if you come to this neat code roadmap, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 18 patterns on your toolkit. So if you have those 18 patterns, actually people like competitive programmers, they have up to 72 patterns. But if you are a software engineer, you just need 18. If you have those 18 patterns well grounded in your toolkit, you can go for an interview feeling confident that even if you lose, the chances are almost down to 10%. Yeah. When I did an interview at the consulting company I work at in Rwanda, I was asked a thing of backtracking question, and then I just solved it immediately because it was something that I knew I was backtracking because they asked me for all combination. So I right away I like, here we go, it's a backtracking. So this is what we are saying. Once you have all of these core patterns in your toolkit, you can solve a lot of problems. You don't need all the questions. You only need the core pattern in your toolkit. So do not be afraid. You can learn all of these patterns. I think the only challenging one there is dynamic programming because it keeps changing. But it can be learned. So the next part is the learning mindset. LeetCode is not hard. If you have learned mathematics, for me, I have an associate in electronics engineering. So if you are already good at math, there are chances that you can be extremely good at LeetCode because LeetCode requires that you just practice and repeat. So when you are small, you learn mathematics by practicing repetition. For me, that's how I learn. I learn by solving by foundation. Take for an instance, if you come back to this roadmap, if you do not have the foundation on trees, you can't solve a trial problem. It's just difficult. You won't know how to solve it. So similar way with math, if you don't have a foundation on algebra, you can solve problems relating to calculus. And if you don't have a calculus foundation, you cannot solve differential calculus problem. When I was doing my degree in mathematics at the time, back in my country, if you, most of the students that were struggling with differential equation, these students, they didn't fully understand calculus in depth. So they struggle in learning differential equation, and that was a problem for them. So lead code is the same. If you have a great foundation, you will realize that a lot of what we will be talking, a lot of what they will be talking in the interview, you know it because you have a very strong foundation. So this is just the same way. You solve, you repeat until a certain time, things like quote reversing a linked list. You have 2, 3, 4 ways to reverse a linked list. Maybe traverse a binary tree. You have 2, 3 ways to traverse a binary tree in the interview, and then your interviewer like, yeah, that guy is the real deal. Like my interviewer was an Indian guy. Is like, yeah, this is the man we're looking for. But that is just to tell you that repetition is important. It's how you build your strength. So what not to do, you solve a problem once and then you leave it. You won't know the pattern. If you solve problem once, you leave it, you won't know the pattern. You never revisit lead code. You just come every class time. We have our session, not class because I'm just a helper, I'm not a teacher. We have our session, you just come and then you just sit and solve this problem. You don't go back to solve it yourself. You are like, yeah, let me see this guy write code, and at the end of the day, you don't go back to solve these questions. It will affect you in the long run. That is to say that in the long run, what you will start to experience is that you will get frustrated, you will have self-doubt, you will have low progress. All of those things, man, they will just like happen to you because the reality of the situation is that you are not just practicing. So because you are not practicing, you will experience a lot of the self-doubt, the issue you experience, a lot of these things because you are not practicing, and it will just slow your progress down. That is the overall thing. So who here have already created their lead code account? Anyone has a lead code account? Yes. Okay. Some people putting their hands up. Yeah, I see. Yeah, okay. So yeah. Oh, okay. Yeah. So yeah, if you already have a liquid account, great for you. You're doing a great job. So now what you need to do is have a Nitco account. So they got Nitco, they got Nitco. You can have a Nitco account. He's a great teacher, to be honest. I too have learned a lot from him. So the next part of our session is big O notation. I'll just do a review for you on big O notation. When we talk about big O notation, it usually comes by solving a lot of problems. To learn big O, to be able to look at a code and say, this code is not really good. You have to solve a lot of questions to know about it. But the idea is that once you see O of 1, or code rating O of 1 is a code that do not need any extra memory, or maybe is not going, is even if you scale the code to infinity, it will run in constant time. It's a fast code. So usually if you were to plot the graph for such code, let me see something. Yeah. So when we talk about O of 1, we usually means that this code is growing like it is like fast, because at O of 1 it means that allow the x as is like 0. So it means that your code operate irrespective of any other things that will affect it. But then when we talk about, so If you want to know, big O notation is just the way we judge an algorithm has your code scale to infinity. So take for an instance, maybe we ask you to find the larger number in an array. We ask you to compare two numbers in an array to find which one is great. We gave you 1, 2, 3, and 4. Maybe let me scatter it around to make it a little bit challenging. 2, 3, 1. Ask you to find the two largest number, and then your first thought was, well, I will do one loop to find the biggest number. I will do one loop to find the biggest integer, which is 3, and then I will do another loop to find the ones that is smaller to a, which is 2. Well, this thought is fine, but then if you are looping, if you're having a loop here and then you are having a loop here, what you are actually doing is what we are saying is, in case we gave you infinite number, in case the number we gave you here is n, which means the number is to infinity, the set is very large, you will realize quickly that your algorithm is running in linear time. This is linear time. Your algorithm is running in linear time. When we say linear time, the graph of a linear function is like this. This is the graph of a linear function. It means that your algorithm is running in linear time. But there is a better way we could do this to make our algorithm running over W. We'll talk about them as we go further, but I don't want to bore you with these algorithms, these time complexity thing. So when you hear of O of n square, what we are trying to tell you is that your code is running in quadratic time. This is a graph of a quadratic function. So we are trying to tell you that, listen, the code you wrote is running in quadratic time, which means your code is slow. And probably if your code is running quadratic time and using O n memory, then it means your code is really messed up. It means your code is using almost infinite memory, and then it's using infinite number of time times 2. So such code will bring the server down. So this is where you hear my grammar run faster than your code. So usually when you come up with this algorithm, it should be about maybe where this algorithm can be granted a little bit, maybe in a tree problem, people will allow you. Yeah, you will get away with it. Like I've gotten away with this algorithm in trees problem. But then some interviewers, if they know the best way, and you give them this solution, you are in a lot of trouble. They start to tell you, they start to put weak higher on your paper script. Like I met up with an interviewer that were just like rude to me. He put weak higher on my paper. I'm like, okay, no problem, because I have to have interview people, so I know how I go. Yeah. When I was on the other side of the fence, I was like, yeah, when I was in the jobs, checking for a job, I knew how I was feeling bad at the time, because I didn't cross over both. But if you are at the interviewer side, you interviewing someone for a role, you realize quickly that you don't want weak people. So you will feel bad when you are not the interviewer, but the day you are the interviewer, you will realize that, yeah, the candidate should have given this thing a little bit of thought. So we got linear arithmetic time, that is O n log n. So if you hear about log n function, this one can be considered most often. I won't be talking a lot about time complexity, because I believe wait. Okay, sorry, actually not. I get it. Oh, I get cut off. Oh, me neither. So, Ash cut me off this computer. Oh, what happening? Sorry. Oh, I got cut off. I think I'm out of the meeting. God, come on, come on, come on. What's my browser? What happened just now? I don't know why I got cut off on the meeting.
I think you are muted. Can you hear me?
Hello? Can you hear me?
Yeah,
Can
you are
you hear
live.
me?
You are live.
Yeah, I'm sorry. I'm on Ash. Sometimes these things happen. Ash Linux, the OS. You
Okay.
sometimes get, yeah. My browser sometimes trip. But yeah, so what I was talking on was I have to go back for my slide. I don't know if I get it here. People talks. Introduction. Introduction. Mhm. Okay. So okay. Yeah. While it go. It go. Okay. So yeah, I was talking about this of the before I get caught off. I think it was my pen that did it. So I was talking about log and memory algorithm, and this algorithm the algorithm that will split the input into two. So if you're having an algorithm that operates in O log n time, you know that a log and memory function is a function that is decaying, is a type of decaying function. Someone say something is in log and memory time, you will understand that this thing is like a decaying function. So which means instead of always getting the input, you always try to divide the time taken into two. So that is like something you have to keep in mind. And an exponential algorithm, which is something around e raised to the x, this algorithm is horrible. Try your best to always like avoid it. So if you did attend your big U notation session, you will realize that most of these things were taught there. And one of the things I want to speak on is cheating coding interview. A lot of cheating tools exist these days, but like now Google is trying to find a way around it where you have to take your interview with the camera on you. So um the best thing I always tell people is train or practice. Just practice. That is just the only case, right? Sometimes you might try to cheat, like everyone has done it. Even me included. The first time I started to do DSA, like around 2023, 2024, 5, the beginning, yeah, I had a lot of cheat papers, but still, it won't help you. At the end of the day, if you don't practice, you will realize that you don't just know some of these questions. So there are a lot of cheating tools exist. I've heard about them, but please avoid using them. They won't help you in the long run. They just make you will feel less confident in your skill set. So practice harder. You can learn this thing, trust me. So so for today's challenge, we will be solving two major problems. We'll be looking at these two problems, and I'll be coming up with a series of solutions, and then we will brainstorm, and then we see how we can attack it. But these are like easier problems. One of the things to always do on lead code is to start from the easier and then migrate to the hard. Do not start from the hard. You can't even start here because you won't answer the question. But just to say, don't start from the hard and then try to go to the easy. it won't work. You have a lot of issues. So before we jump into the problem solving, I'll take a few questions. Anyone has a question for me? Yeah. Yeah, you can go ahead and ask your question.
All right, thank you, George. Good
Yeah.
evening, Timmy. So, one, I think two questions. The first one is when you mentioned problem solving and memorization, and I definitely understand that. I think everybody here does understand that. And while I agree, can you hear me?
Yeah, I can hear you. I can hear you, sir.
So while I agree the problem solving over memorization, but at the point starting when I started, right, which is recent, just last year, so I had issues with merge sort, for instance. I mean, sort the algorithm basically, and I found out that I wanted to know how to. I understand the situation. I understand the whole thing, divide and conquer, right? Makes perfect sense. I could explain it, but when it comes to applying it, I see a problem. I know. Oh, okay. Let me divide and conquer this. Writing the code itself, I got to know that okay, I need to know how to write merge sort without consulting Google or anything, right? So I learned how to write merge sort, quick sort, and quick select. I had to memorize them. To be honest, one of the painstaking thing I did again was if I'm going to pick DSA tomorrow, solve a problem, different problem entirely, different pattern, I have to write the algorithm I wrote yesterday. I had to write it in paper or in my text code, right? Just to know that, do I still remember this thing? And when you talked about memorization, do you think that it is just absolute problem solving over memorization, or could we balance it and say maybe 90% or 85% of problem solving,
Yeah.
and you have to write some algorithms? What do you
So
think?
the memorization, are you finished?
Yeah, sure.
Okay. So the issue of memorization is knowing what to memorize.
Oh,
Knowing what to memorize and what not to memorize. Take for an instance, you should know Java, you should know some things in Java, like some things you should know intuitively. And when we talk about memorization, I'm talking about do not put your brain under stress to memorize things. What you do, how to become effective at memorizing is not to store things in your temporary memory because you will forget. So what I'm talking about is this. What I'm talking about is this, right? You build, because when you are learning, you are building circuits in your head. This is what is happening in your head. When you are learning, you are building these circuits. Your brain is like firing a lot of neurons. So take for an instance your first time writing merge shot, you realize that, oh, I have to be able to get the low and the high. I have to be able to get the low and the high. I have to use recursion, and then I have to first merge from the low to the middle. Then I merge from the middle plus one up to the high, and then I call the merge function. So in doing those ones, you realize that, yeah, I have to do it. But the first time you do it, you realize that you feel like you know it, but you don't know it. That's the reality of the situation. But you do it the third time, you realize that, I know this thing, or I can try to write this thing on my own. When you are writing it, you find your limitation. Like when I was learning merge swap, yeah, I found my limitation. When I was doing quick select, I found my limitation. So what I want you to do is to learn how to do something called intuitive memorization, where in the case that you have written this problem a lot of time, you have written this pattern, not the problem, because I don't want you to memorize question. It's totally non-essential to me. It's useless absolutely to memorize question. I've become a victim of memorizing question because I had an interview. Let me tell you a story. I had an interview like this interview was like, they told me to prepare in 1 week. So I found around 20 problems strong. I memorized those questions because I was told by someone that these are the questions they are going to ask you. You have to know it. It was like I think it was for Amali Tech. So, and then I knew those questions by heart, bro. Like when I went for the interview, I was like, I'm ready to go, ready to code this thing up, bring all my cheat paper up, put it on before my computer, getting ready to solve. Ready. But then when the interviewer came online, he asked me some basic questions. So he was like, reverse and everyone key. And I'm like, ooh, I have seen that question before. I knew that question. But I didn't know the pattern to solve that particular question. So now like only if I would have known about how to apply rotation in only if I knew about powerful sort. Only if I'm going to not learn that question and just focus on memorizing powerful sort, yeah. And then he asked me another question again. And even that one now that they asked me was all my list of questions that I've already memorized. But then when I start to read it, I quickly realized one thing about Java syntax. Java doesn't obey under pressure. Java doesn't obey under pressure. So I started to hit a lot of errors, and then it was errors after errors, error after errors. So you can memorize. That is the truth, but know exactly what to memorize. Don't memorize question. That is just what I'm telling you. Focus on memorizing pattern, then memorizing question. I hope that answers your question.
Yes, it does. Yes,
Yeah.
it does.
So
One more
just
thing.
yeah.
Okay. While I'm solving questions or problems, rather, do you advise? I mean, I know there are some situations you probably shouldn't use some. I don't know. Maybe it's local. These are collections. I don't know. Do you advise to use collect like Java internal collections and all these things? You know.
Yeah. The like for heap questions, you quickly realize that in heap questions, most often people say, you can just flip or if you some people say if you flip because by default Java's default priority queue is a main heap. So if you're trying to solve a question that requires a massive, some people say just chunk all the element with a negative value and automatically get a massive. But then when you are trying to reverse those elements, it become a problem. So for me, I usually advance, put a collection in the heap and then reverse it and then store your elements. And no one will hold you responsible. But here is the thing.
Yeah.
Don't do the thing that is usually impact on one line solution. One line solution, you got nothing to learn. And sometimes your interviewer know these things. So you can everything is about balance, right? You want to know where to use internal function and where not to use internal function. Yeah.
Okay. That's good. Thank you.
Okay. So is there any question before we go to solving problem? Yeah. Yeah.
Yeah,
Yeah, you can come.
hi, good evening, everyone. Can you hear me?
Yeah, I can hear you. I can hear you.
Yeah, thank you so much for the session so far, George. I really appreciate it. So my question is this. I'm just going to go with this assumption that a lot of the persons here usually program with Java, but I wanted to know, like, and to ask, like, how would you approach a situation where you're maybe solving a program in a language that maybe lacks some standardization in the default library, like out of the box. For example, the way JavaScript doesn't have like inbuilt priority queues and things like that. How would you handle situations where you have to solve a problem that might require you to use that?
The sour truth about this is yeah, I've come across that challenge with Ross in interview. The sour truth is but the honest truth, if you really want the honest truth, is usually tell an interviewer that because anyone that is giving you DSA question, I believe they don't really get time for the language you use. Find a language that is effective at DSA because they have special languages. All language you can do DSA in it. Take for an instance, Go is one of the most challenging language. Go and Rust. They are one of the most challenging language to use to tackle DSA question. That is just the truth. other people will not want to see it, but the truth is the truth, right? I remember when I used Go before in interview, I had a lot of issues because I come from a Java background. I'm expecting you to have I'm expecting you to have maybe while loop. This language don't have while loop. I'm even expecting you to have a way that I can do a set. This language doesn't have a set. They're telling me to use map. So sometimes interviewer allow you to use Google. It's okay, but some interviewers don't allow you to use Google. So at the end of the day, you have to pull your own data structure up. So the best advice if you are using a language that is not data structure oriented, one, switch. Learn how to code the primary data structures. If you are using Rust, if I'm using Rust, I'm trying to code a linked list. I know I have to find a way to go around the tree. I'm just from work, I'm feeling a little bit tired, so forgive me. I have to find a way to go around the tree. So for mostly as your interviewer, right? This is why you don't want to use a language that is not for DSA, because DSA is for skills. I keep saying it's not talent. It's not something that, oh yes, I can program, then you know it's a skills. So the best languages are C++, Python, Java. If you pick any other language out of these three, you will have some issues and you will have to practice well. I did a repo because I ran into a lot of issues around Rust when I was doing interview. So if you are here, you want to do DSA in Rust, me and a certain guy we've been working on this repo. Okay, what is it? So either you learn the language in depth to the point that you can just code the data structures out. Like this is a repo that we did almost every single thing you need to do in Rust is here. So for those that are trying to do something in Rust, you can Rust for interview, you need to look at this repo before you go and fill. But Rust is not DSA oriented. You're going to face a lot of issues. Yeah, you're going to face a lot of issues, except you master the whole language. So that is just my advice to you. Either you switch or you master the language. It's simple.
Okay. Thank you so much. Thank you.
Yeah. So any other question? If there is no question, then we move to the challenge and we try to look at it. Any other question? Any question? Anyone has a question? Okay. So no question. We try to get into the challenge for today. I will solve it on NITCO first. NITCO. Okay. So because okay. So I'll just reset it. This is one of the solutions. Like I said, the solution doesn't matter. It's you understanding that solution. If you see a solution, usually when I see a problem, another trick, when I see the problem, I try to map that problem to a pattern I know, and I can't map it to any one of the pattern I know that can solve it. I'm going to look at the solution and try to figure out if I can understand the solution on my own. That is what I'm going to do. I'm not going to waste my time trying to spend 40, 50 minutes. In fact, good engineers that I've seen, even the quote-unquote competitive programming god, when you don't know the question, immediately you try to map that question to a pattern you don't know. The first advice is go and look at the solution. See if you understand the solution and then the solution in depth. Don't waste your time trying to become a genius. It won't work. Go and figure out the solution, and then in the future, when you see any question related to that particular solution, you will be able to solve it. But trying to waste 4 hours on a question, it doesn't make sense because you have 3,000 questions to go. So why are you wasting 4 hours on this question? So the maximum I gave myself on a question, I think you can even see if I reset my timer here, it's like 3 minutes. If I can't solve it in 3 minutes, then I can't solve it. It's obvious I can solve it. I'm going to look at the solution and pass by it. That is just simple. Because I have 3,000 problems to go. I can't be looking at this one pattern. Don't spend 2 3 months on a single pattern trying to figure out that pattern. No. Move forward, learn other pattern, and you'll be good. So I'm going to go to needful, and then I want to go to needful. A lot of these questions are questions that are solved, but I'll try to resolve them. I don't know. Okay. So I don't know if I'm cancel my progress. 175. Why it's not working? You want to reset? Okay. So we can't continue to be right? Okay, I think I reset it. So continue to be this is the first area to start if you want to learn about how arrays work. So in this question, it says you are given an integer array, return true if any value appear more than one in the array, otherwise return false. So you are given this array of integer. I'm going to do Control Shift V. Control Shift V. Okay, so I just wanted to take a screenshot of the question. So you are given this question, and what they are saying is giving an array of integer, return true if any value appear more than once in the array, otherwise return false. So this is a very easy question to understand. If you see a value, return true. Okay, I will have to go to scalar draw. I will have to say done, and then download. Save this thing. Save it. And then I'll have to come here, take this image. Okay. Okay. Yeah, I have a lot of issues. This image is somewhere. Yeah. So zoom in infinitely. Okay. Now we're here. So one of the things I experienced in Kikali was I was told to go in a Google Doc. So you are given an integer array norms, return true if any or more value appear more than once in the array, otherwise return false. So if there is a value in this array, this question is very easy to understand. If there is a value in this array that appear more than one, we will return true. It means that, what's this? Come on. It means that we have encountered a value will return true. Will return true, otherwise we return false. Will return false. Some approaches to come up with in this solution. The first approach you will think about if you see a problem like this. If you see a problem like this, the first approach, you might want to say you want to go over and over, you want to get 3, you want to get 1 story somewhere, and then check if 1 exists, and then you be comparing. Well, if you do this, the algorithm will be O n squared. If you try to do that, you have O n squared. The best thing to do whenever you are given, control Y. I think I lost the image. Bring it back. Whenever you are given a duplicate problem, whenever you hear duplicate and they're asking for unique, what should come to your mind should be few things, right? The first thing that should come to your mind should be set, a set. So you should think about the set data structure. The set, what the set allows to do is set cannot contain duplicate. So whenever you have a set, you can contain duplicate. So our approach to this problem is going to be, what we're going to do is we're going to have a set, and since set cannot allow duplicate, we want to take one, put one in this set. We want to take two, put two in this set. And we're always going to be asking ourselves, before we put the next number in the set, we will be asking ourselves, does 3 exist in this set? So before we put 3, we are asking, does 3 exist in this set? No. So the algorithm is like this. I don't know why this image keep playing hide and seek. Why you keep playing hide and seek? What's it? Okay. I hope you don't go and press Control Z. So the idea I'm saying is this: you have a set. Whenever you hear duplicate, pay attention to these keywords, because these keywords are important for your pattern matching. Whenever you hear duplicate, you are trying to find unique, and then you hear duplicate. Always think about set. Always think about set data structure. Your primary thought should be, I'm thinking on set, at least consider set. So now for this problem, what we are going to do is, there are several ways we can solve this problem, and actually there will be 2 ways we'll solve it. The first way is, we want to take 1 and place it in the set, and then we want to ask, when we come to the next number, does 2 exist in this set? Let me start back. We ask ourselves, does 1 exist in this set? No, we put 1 there. We ask ourselves, does 2 exist in this set? No, we place 2. We ask ourselves, 3, are you in this set? We say no, we put 3. And then the last one is, when we ask ourselves, does 3 exist in this set? It turns out to be like 3 does exist in this set. The set contains 3. So because the set contains 3, what we will do, we'll return true. If the set contains 3, what happened to my pen? So we'll return true here. What happened to opacity? So the pen is messing up, but you kind of like get the idea. Anyone has a question on this approach? Is there any question on this approach? Yeah.
Right, thank you, George. So my question now, based on this approach of using sets, to kind of track, right? So what if this number list is sorted, right? So the set like the best approach to keeping an extra speed.
So there are series of approaches to use, but the reality about the situation is, if you sort this array, right? One approach, the approach you are talking about. Let me try to make this thing bigger. If you sort this array, right? So let's say the array is unsorted. I don't know why this thing my pen is misbehaving. But it's because I zoom. So let me zoom out. So I think we understand the question. If you sort this array, maybe you are given an array of 2, 3, and 4, and then you decide to sort it. There is a cost that comes with sorting. Sorting is not free, right? So whenever you sort this array, you will realize that if you sort this array, okay, I think this one is not scalar. Let me find some scalar numbers. This one is like a sorted. I don't want something that is sorted. I want something that is scalar. We get that is all over the place. So we have 6, and then we have 3, and then we have 4, and then we have 1, and then we have 2, and then 5. So if we sort this array, what we will quickly realize is that there's a time taken for us to sort it. In best case, Java is using merge sort under the hood. So whenever you do a sort, Java always do merge sort. And if you know the time complexity of a merge sort, so let's sort it first, then we'll get to it. You get 1, 2, this is 3, this is 4, this is 5, this is 6. In best case, this scenario, Java is using something of O. Let me zoom out a little bit. Yeah, this one work. So in best case scenario, Java is using something of O n log n. This is the cost of sorting. So when you sort the array, it's easier to solve the problem. You won't use extra space. That is the blessing. But then you have to deal with this. You have to deal with this now, because this is linear arithmetic time. It is not so good, but it is manageable. It's okay. But this is your trade-off. This is what you are trading off. This is what you are trading off. That is the honest truth. But if you sort this array, what you could do is you could try to compare 2 or 1 and see if 2 is exactly like 1, and then you return truth. Or you could try to see if 2 is exactly like 3. 3 is exactly like 2, and then you could do like a linear scan, and then you solve the problem. But there's a cost that comes with it. That is what I'm saying. So sorting is another solution, but you pay the price. I hope I answered your question. That answer your question?
Yeah, thank you. That is clear.
Yeah, and another one, my solution, the one I'm taking on, you pay the price in space complexity. You have something of ON. ON is better than O n log n. This is better in terms of time complexity. But then because I'm using extra space, so you will realize that I'm using ON space, right? So this space I'm using is, so if you are looking for, if you have a little bit of resources, then my solution is messed up for you. Then if you use this is why we always talk about trade-off in the group chat. In tech, you always have to find trade-off. Those that are using AI will be extremely productive, but then the trading their problem solving ability to a certain extent. Even me, to my office, I'm usually in the midst of my boss telling me, "Oh, Josh, we can't be sitting waiting for you to come up with your perfect code. We have to use agent to go faster." So what you will realize is that whatever thing you want to do, you have to do the trade-off, right? We have to do the trade-off. Today, I went to work, I writing or script. I was taking my own set time writing it, then yeah, my boss is an Indian. He told me, "Look, Josh, we don't have time for you to be writing code here. We want solution. Business people, so you have to trade it off." In my startup again, I was writing code by myself. And then my other team member, he used agent. So he told me that, "Listen, we can't be waiting for you to come up with this perfect script, perfect code. We don't have that time." So I had to find a way to balance it. So you always have to think about trade-off. There's always a kind of stuff in tech, and we'll continue to be a stuff in tech. There's something in tech that you just have to deal with. So if you use my solution, you cut the time down to linear, but then you trade the space. If you use the other solution, you increase the time, and then the space will be reduced. You reduce the space. So I hope it makes sense. Make sense?
Yeah, great.
Yeah. So these are the two solutions to this problem. They are the third solution, but I don't want to discuss the third solution because you already know the third solution. You you do the first scan, you collect the larger element, and then you try to find if that element exists, and then you have to do like double scan of the whole array. So that one will take you like a whole lot of time. But I'll try to see if I can code the two solutions out. Yeah. So I'll try to see if I can code the two solutions to the best of my ability. But these are primarily the two solutions you run into in interview. So the first thing I want to do this will help me to input all the stuff I need from the Java library. And then the solution you were talking about is this. You sort the array, and then after you sort the array, what you can do, say r equals 0, and then we want to say r less than none start length. Oh yeah. So when you sort the array, what you can do, you can compare the elements. You can say, so this will help give us the previous element, and then we want to say if that element is, no, we're making a mistake. We should start from, because we are comparing the previous, we'll start from 1. So, okay. I'm going to say r minus 1, because if we don't start from 1, we'll get index out of bound. So, yeah, I think so. So, what he was saying is this solution. Okay, so this one will come first. So, what he was saying is if you are given an array like this, the solution we was talking about is if you are given this array like this, you can, if the array is sorted, which is in this case, if I zoom into this image a little bit, you can see we have 3 here. I don't know. Let me do a refresh. So I don't know, my pen is misbehaving. But what he was saying is if you sort the array, you have 3 here and you have 3 here. You can compare the 3 at this position with the 3 at this position. If both of them are the same, you can return true. So you can return true that you are seeing a duplicate. This can only happen if the array is in a sorted array. If the array is already sorted, if you have the array to be sorted, if you have 1, 2, 3, 4, then you can be able to say, is this element at this position same as this element at this position? If both of them are the same, then you can return true. So that is what he's trying to say. But what I'm trying to say also is that you can use a set to try to solve this problem. And let us see if we can run this first solution, and then we'll see if, yeah, it's correct. Okay. Turn out the videos. I don't even think we need it. Illegal sort of expression. Not really needed one. Yeah. But that is like the idea there. The idea is you want to sort the array, and then you compare the number of these two positions here to what, right? This thing is, why is it saying illegal start of expression? But this is the idea. So you can submit it. Sometimes you can come up with a solution and submit it, it can work. So you have to be careful. You have to be careful how you go about it. Sometimes you come up with an extremely fast solution and then it can work. Yeah. But this is just what I was saying. The next solution could be you use a search or a set. Am I making a mistake with this? Oh. So you use input Java. Yes, this will be it. What is the issue? Okay. So the next solution is this one. This solution here. Okay. But with this solution, we want to use a set, and then we want to have a set of integer. If you think I'm making some error, you can make a comment in the chat. You can make a comment on the call. Hash set. So there's a way. This is the way you get set in Java. I'm not sure if this is getting everything, or it's coming from me, or it's coming from the Nico platform. But what you want to do, the idea here is you want to go in that set, collect every number, and then you want to ask if that number is like within your set. So, is it enough? Okay. So you want to take the set and check if it contains no. So if that number is already there, we'll return true. Yeah. Else, you want to say set. We set. Yeah. So if the number is not there, so the idea here is that if the number is not there, we want to, is it put or add? Whatever we will figure it out. So we want to, if that number doesn't exist, we put it in the set, and yeah, I think set should be put. We return false. So in this case, what we are saying is, we have a hash set. We want to go in that hash set, and then we want to check if that number exists in the hash set. If that number doesn't exist, we want to make sure that we are able to put it in our set. So why am I having error with this thing? There shouldn't be an error. I don't know why I'm having error with this. I'm having a little bit of forgetting here. Java.utils. Let me just come here and ask question quickly. Yeah, I'm correct. This statement input. I don't know why this guy platform is. Is it coming from Nico platform? Let me solve it on Nico and see. So why am I having issue importing all Java libraries? I've done this thing 100 times. Yeah. Why is it E because type of expression? So I don't know where some of these coding platforms they usually give issues. So let me come on this side. Input Java.utils. This should be it. This should run it. don't know why I'm having issue with my input statement. Okay, then this one is add. Set of content. Yeah. Okay. Content. Content. I'll find out with the way. So I is equal to 0. This is the long way, but it's not bad. Plus plus. Multiply R. Vector here says R. Simple. Yeah. No, this is not. C'est contains or contain. I think I'm making a mistake. I'm making an error on the contain. Set of contain. I don't know why I'm having this issue, but yeah, I'll just look at my previous summation. Why I'm having this issue?
Contain should have S.
Yeah, but even if it have S and I'm still getting the error. Yeah.
Yeah, so I think the issue is coming from the import. If you watch, he's talking about you do not find a symbol.
Yeah, but
the import. Yeah.
amazing.
Collection.
But this is correct. Like, yeah.
Is it possible you just import set direct? Import java.util.set. Maybe
I don't know, but it seems like it coming from these platforms because this should work. Why is not working today? Okay, not an issue. Maybe it's because I'm doing live session, so yeah. Like I told you, Java can make people under pressure. Okay, I'll import set directly and then see. Okay, out. Like, okay.
Oh, can I make a suggestion?
Yeah.
So I just looked at your for loop now. After you have if set dot contains num. Can you hear me?
Yeah, I'm hearing you.
When you have if set dot contains num, return true. That's fine. The problem I think.
I've seen it something like this.
Okay.
No.
Yes, but besides that, yes. So yes, that you should add that. So add that your negation. Then beside that, your set dot add num. Okay, it should work now. If it doesn't contain your set dot add as an else statement, it should work either way. But now that you have that, but let's run this first.
I don't know, but like this is the solution I wrote this morning for this thing in work. So
Has it worked now? Have you run it?
yeah, let me run it. In fact, let me remove this one from up here.
So where's your other return statement?
Here is the
I can
return.
see the outside, okay, it's there. So
But let me just run it.
You don't have to import. You don't have
Let me
to
run
import
it.
your set and all. So move this your set dot add as an else statement.
Even if I'm making an else statement, the reason it cannot be an else statement is because this can be an else statement.
No,
If this is an
your
else
set
statement,
content should be a negative now. It should be
Can you
if
hear me?
set doesn't contain none. Yes, so there should be a negative there.
Hello.
no, yeah.
So it's not a code. It's not a code issue. The issue you are facing is more like a lit code problem. Since you are sharing your screen problem, so it's a lit code problem, not like a code solution problem.
Yeah, because this is
that is not correct now.
this code is correct. This code is like
No.
correct.
If set contains norm,
Yeah, if set contains none, if set contains none means that we have already seen this number, we have already seen this integer before, and we are returning truth. So let me take this code and then carry it to neat code and then see. What am I missing? I'm not missing anything here. I don't know why. I'm not missing anything. Like this should.
Do you have your IntelliJ?
Like
Just copy and paste it in IntelliJ and run.
This is what I'm saying, right? It's accepted here. I don't know. Like it's accepted here. This solution is correct. Like this solution is correct, guys. Like if the set contains this, it should work. It's running, it's working. Let me submit it and then see. It's accepted now. I don't know. I have to look into these coding platforms. They misbehaving a lot tonight. I don't know why they are misbehaving. But maybe because it's live session. But if I take the same code and run it on lead code, it's amazing. If I run this code here, I get error.
The compilation error.
Yeah. Okay. I don't understand what is going on here, right? But it's more like a platform issue because one platform is accepting the solution, the other one is. But this is just it. I'm human. I can make error, and thank God you're seeing it. But the idea is sometimes you have to trust what you are doing. Sometimes what you are doing is probably correct, and then you try to change your solution, you will run the bigger issue. But that is just the two solutions to this problem you might come across. I'll try to look into this issue a little go. Maybe they had because this content they were experiencing downtime. So maybe it's why, but like if you see I've written this solution in Go, Rust, Python, so I know this solution off the back of my head. It is not something that I'm guessing. So the next question we will try to look at is valid anagram. Anagram are words that have the same letters in them. That is just it about anagram. Anagram are words that have the same letters. That is just all you need to know about anagram. Hello? Someone has a question? So
Yes.
yeah, you can ask a question.
Okay, I'm sorry. Concerning the last algorithm we saw, do you have two solutions for that? Because it seems like I left off somewhere and probably you have an initial solution. The one I'm just looking at on the screen, do you have any other one that you already submitted?
Yeah. So this you don't have to write this solution. This solution is not working on this. Oh, now I know the issue. sometimes lead code they get rid of the previous solution. Maybe they might see it or not. I'm hearing a lot of feedback. So what I'm saying to you is sometimes the solution you write on lead code after sometimes the solution you write on lead code after 3 to 4 to 5 months they might see that solution to be invalid. Say for instance, I wrote an original solution to Facebook problem before. Facebook gave a problem before. What was the solution I wrote? I wrote this solution. I think it has 1,000 views on it. Show more. Okay, this solution. It was 2 years ago. I wrote this solution. At the time, I didn't think we had the oil around here. But I wrote this solution. It was a binary set solution I wrote in Python. But I quickly realized that this solution has now, if you read the solution now in interview, they won't accept it. Maybe an interviewer will accept it, but they won't accept it because someone came up with an even better way to do it. At the time, this question was new. As you can see, a lot of people are telling me, thank you. What is it? A lot of people are telling me, thank you, you did well. I was thinking about similar stuff like this. And even some are even saying, nice, full, exactly, full, all type of stuff. But the previous solution you might come up with in lead code, those solutions, after a certain period of time, those solutions might not be valid. This solution might not be valid. So this is just something you have to keep at the back of your mind. And I'm running into one of these issues currently. Like the solution I currently wrote here, the solution is not valid now. So you live are having the sorting solution will be this one, right? This one. This one, you sort the array, and then you can come. Once you sort the array, this is the solution that is currently being held. Now, I don't know why it's being held, but this is what it's working. Yeah. So this one we sort the array and then we compare the numbers at each position. So this is the one that is currently being held. So this is the one that is currently being held. I will have to look into why lead code is not holding that solution. Maybe they see it to be efficient currently now, but if you run this solution, yeah, this one's supposed to be one.
Hello.
This one's supposed to be one. You have a question to ask?
Yeah, I'm saying I can see. Okay, I can see your screen now. So what I was asking is if you have a solution you've already sent yourself in this class, because I left off somewhere, and when I came back, I was just seeing the particular solution that was showing error. So I don't know if you've already submitted a particular solution.
Yeah. So what we were discussing. I'm sorry you got caught up. Can you mute your mic? Muting your mic will be okay for us. Okay. So I introduced this solution, which was the first solution I introduced. What I said about this solution is, if you were here, I said that this solution, the problem here is giving an array of integers, num, return true if any value appear more than once in the array, otherwise return false. So what I was saying is, if you sort the array, it was not even me. it was not me that brought about this solution, it was someone who said it and then I had to code it up. So he said what we can do is we can sort the array, and then if we sort the array, we can compare these two numbers. We can compare the, because if you are given a number, say for instance you are given 3, 1, and 2, and you are asked to check for duplicate. Sorry, let me make this one 3, 3, 1, and 3, maybe 4, 3, 1, 2, 3. You are asked to check for duplicate. What you are asked to check for, if you decide to sort this array, what you will experience is that you will have 3, 3. But then I told him is if this solution will work, but you will have to trade n log n time, because this solution is not linear. This solution works in O of n time, so you will have to trade that particular time complexity. You have to trade it. So what it goes to show you, that this solution, although it's work and how it works, because we want to find duplicate. So after we have sorted the array, we want to compare this 2 with this 1. That's why you see I'm starting from position number 1 in the code. I'm starting from number 1 because I want to compare 1 with 0. I want to say r minus 1. But then if I start from 0 and say r minus 1, I will get out of bound, which means I'll be talking about here, and it doesn't exist. I will get out of bound. I will get an error. So what I'm saying is, if you start from number 1 and then you say 1 minus 1, you get 0 for r, which means you are comparing these two things. If the number here and the number here, if they are equal, if these two numbers are equal, you can say that you can return truth. If otherwise both of them are not equal, you return false. But you have to sort the array. But what if you are given a huge array? You are given an array of O n time complexity. You are given a very huge array, like millions of elements. You're trying to sort the array, you have to wait Java sort the million of elements before you can do the linear search. So it was what he came up with. And this was the first solution. Where I put it. This was the first solution. I coded up. And then when I coded up, yeah. So this was the first solution that we came up with. But then the next one I came up with, but when I went on LeetCode, I started having issue. So the issue was coming from their platform. The next solution I talked about was, in order to not put all the weight on Java to do sorting for us, what we could do, we could come up with a set, and then we could use that set. We could come up with a set, and then we could use that set to do most of our things. So we'll come up with a set of integer, and then what we want to do, we want to scan the array and check if that element exists in our set. And if the element is already existing in our set, we return truth. So I'm just reviewing you. After here, you can take your own set time and you go through it. I will put the code on the GitHub gist. So most of the code will be there. So the idea I'm trying to use, but then I was getting that error was, if the set contains norm, if the set contains norms, I think this is illegal. We return false. We return true. I mean true. Else set dot add. I'm coming. 1 second. 1 second. I'll answer all the questions. So this is what I was trying to come up with, and then I'm having the error. It's working here, okay. As you can see. It's working here. But I don't know what is going on with LeetCode. Yeah, and I'm kind of like tired of it. I'm a little bit tired of with their platform. But they've been having issue. So yeah. But this is the other solution to the problem. So you still got any questions?
Can you hear me?
Yes, I'm hearing you.
Yes. Okay, there's an approach I have in mind. I don't know if it will be efficient, more efficient than the ones there are. Okay, what if we just do okay, from that for int norm, int norms, what if we just do set.add and we add everything in that integer array,
and after that, we just compare the size of the set with the size of the integer array. If the
Yes.
size is equal, okay, yeah. So if the size is equal, we return false. If it's not equal, we return true.
Yeah, that's another solution. Yes, yes, that is another solution. So what he's
Can I
saying
make a
is,
contribution, please?
yeah, you can make a contribution.
Yes, so I think that solution would work, but the solution that the instructor has given has an advantage, and that advantage is early exit. It means that so the instructor's solution, at the very instance where it cites a duplicate, the iteration ends. So because it returns true, so the iteration ends at that spot. So let's say you have 100 elements, and it cites a duplicate at index, that's 100, that's 0 to 99, and it sees a duplicate at index maybe 20 or something. At that point it stops, it doesn't bother to get to index 99. But if we then add every element of the array to the set, it means we are going to go from index 0 to index 99 before we now check for the size and then return true if the size
Yeah.
of the array is not equal to the size of the set. Yeah, so imagine then that you have maybe 10,000 elements, and then maybe using the instructor's algorithm that would just break the very moment you cite a duplicate. So maybe you see a duplicate around index 100 out of 10,000 elements. Meanwhile, if you decided to add every individual elements to the set, you are going to go from index 0 to the very end. You get, so that early exit that the instructor's algorithm has
Yeah.
is an advantage.
So yeah, that is one of the advantage of. But normally the truth is normally the two solutions will eat a lot of space because my only has the advantage of early exit. But then in a case where you have million elements, I can exit early. So yeah, that is the only advantage I get, the early exit. Yeah, but in the other solution, yeah, but the other solution you have to use n space. While this you have to use or debit space pertaining to the number of elements. But yeah, that's like a fun solution to solve this problem too. That is like another good solution to solve this problem. But this problem has a lot of approaches. But when I saw this, I think it was yesterday, and then I saw it. Let me just write the solution out. But now LeetCode is the same solution I wrote on LeetCode. I'm writing it. They don't want to hold it. Okay, but it's okay. We have to go. We have to move to the next question. We have to move to the next question. Yeah. Is that a female I'm hearing? Yeah.
Yes.
You want to ask a question?
Gloria.
Yeah, Gloria, ask a question.
No, yeah, I want to appreciate you for this wonderful section.
I can hear you, Gloria. Gloria, you are coming in broken.
Can you hear me?
Yeah, I can hear you.
All right. So I said I want to thank you for this engaging section and the site you made so far. I also want to apologize to the people on the call. The call was scheduled for an hour, and we are currently at 2 hours. So I was thinking maybe we should just round up, and the next question will be solved on Saturday. What do you think about that?
Well, whatever the team plan to do, we can do it. If they want us to solve the next question on Saturday, I don't have an issue with it. But remember, we have 150 to go, and we are just on number 1. So, guys, you people want us to solve the next question this coming Saturday, and then we can wrap it up.
Yeah, so I think we should, stick with that. By next week Saturday, we continue.
Oh, okay. Because the next question was going to be a little bit challenging because yeah, this one is just question number one because I was observing the time. But when I ran into that issue with lead code, when I ran into that issue with lead code, it was what caused a lot of the time to waste because I thought the error was coming from me. Usually, when you have an error, you always blame on yourself before blaming the platform. Then to take a credibility. So the next question is valid anagram. This one should be very straightforward and easy. Um, you are given these two screen and then you are to check whether all the characters here they are in the next screen. So you have to check them. So in the next maybe Saturday, in the next time we'll try to solve this question. We will use NeetCode because NeetCode is currently giving some errors. You will use this platform to solve most of these questions because I don't know what the hell is going on with this thing. So you will use this. But is there anyone who feel that we should continue the session or everyone want us to close? Or we should write the solution and then you come the next day we explain it, or we should close it up? I already have two persons. Let me see the next. Two people. Sorry. So the others, you people want us to. Yeah. Yeah, you are free to talk, better.
All right. Good evening, everyone. Is my voice coming out?
Yeah, we can. Yeah.
All right. Thank you very much for this engaging session. Honestly, not for me, I would have said let's continue, but it would be nice if we continue on Saturday. Then on that, I have one question regarding VSC. Like you have earlier mentioned, in the Java ecosystem, we discover that there is a lot of steps to cover. Like, when do you recommend data structures and algorithms for someone that is a Java developer? Because I can remember when I was very new in Java, I was advised to take data structures and algorithms. I did, but it was a regret. I think I understand what you are doing now better than when I started before because I have gotten some knowledge of the fundamentals. I'm good with the fundamentals now. So I kind of feel better learning this data structures and algorithms. So what advice do you have to offer when it comes to that area in order to maintain balance?
What I will tell you is, you should always try to review the fundamentals. Get basics before you go further. And if you keep skipping DSA, what will happen? You will miss a very big opportunity before you realize that maybe I should have focused on this thing. Because usually when I used to, even when back in those days, my senior programmer at the time, he's a Ghanaian. When he told me to focus on design pattern in Java, I was like, where will I use it? It's not essential. But then I was given this task at, I think I was on a World Bank project. And then they gave us this task. And they wanted to see who has design pattern skills and DSA skills. So I built my project. My project was great. It had a nice UI, but then when we went to present, they start to ask me question on what is a factory method, what is a momentum. Those things that they expect you as maybe intermediate Java developer to know about. And then I had no knowledge on it. And then what become of that was I missed the opportunity. But now, if whenever you feel uncomfortable learning DSA, it's the more time you should learn it, because the more you feel uncomfortable, it means that you are learning. But if you always want to be like in your comfort before you can try to learn it, you have a lot of issues, because you skip it today, you skip it tomorrow, you skip it next week, and then it will just be the same old cycle you're repeating. So my issue to my advice to you is be consistent, learn the basics, yeah, and keep going. Any other question?
No. I don't have any other question. I'm good. Thank you very much. It's clear.
Okay. So if we all agree to close the class, we can go ahead and then try to close it. Esia,
Yeah.
do you want us to close it?
Judge,
Yes?
so Bright just took permission, right? Can you hear me?
Yes.
All right. So it seems next week you'll be solving more of the algorithm, right?
I'm trying to hear her. Okay, what are you saying?
Can you hear me?
Yes, I can hear you.
So I'm asking about next week. Will you be solving more of the algorithms so we can extend the time of flyer? Maybe make
Yeah. So next week, yeah, I understand the time is over. We will close it up. Next week, I will be solving a lot of. Next week, when I come, I won't do anything relating to introduction. So there won't be no introduction next week. I came from work. I'm a little bit tired, but next week I won't go to work on Saturday. Next week we will be solving strictly. I won't introduce you to any of these concepts. That's why I make the flyer available so you can try to download it. I will stop here because a lot of people are already tired. So I will stop here. I will respect what Gloria is saying. I will stop here, and then next week, when you come, please review the fundamentals. Like review some of the things I was doing here. A lot of people, maybe it wasn't unsettling for them, so they, yeah. So review the fundamentals. Next week when I come, there will be no slide. You will jump straight into it. Yeah. But next week when you come, remember when you come next week, we will have to add the problem set up. So now we already decided to skip this. We decided to push this problem over to next week. So when you come, this one I know everyone should know this one. It's two sum. This is like the easier one, and we'll solve also grouping anagram. The roadmap is already available. You can come to NITCO roadmap. You get yourself familiar with it. I love when people correct me. So feel free to correct me in this class. I'm not invisible. So come learn and try to challenge me next week. It'll be okay. I want this class to be something that not just me doing everything. Like I saw a lot of good things today. People challenge the solution. People came out with their own solution. So I'm encouraging you to do that. Feel free. Whenever you see a mistake, I'm going astray. Challenge me. Have a better solution. Present it. And I'm here to learn too, not just to be, all teaching you up. So yeah. So we'll end it here. I hope you learned something today.
All right. Thank you very much. And for
Anybody has any other question? We talk about it and then we close it up.
I think there is no other question. So thank you very much, George. Like I said earlier, I sincerely appreciate your section. So for other persons, we are going to increase the duration for 2 hours for next week. So please take the flyer will be added. Thank you very much for your time.
Okay. So I'll see you people next week. Yes, this Saturday, same time. Please get yourself a coffee.
Same time, but we can start by 8:30, but we'll extend for more than an hour.
Yeah, we'll do that. Okay. I'll see you.
Thank you very much. Good night from Nigeria.
Night.